This is the first assignment for the 6th quiz in the first trimester. So there is this page of notes to print out and refer to, and it has for linear quadratic systems, this is what we are studying, solving these. Now it has an example of each kind, one where there's one solution, no solution, and two solutions, and how to do the math. So basically the math involves setting the quadratic equal to the linear function and then using an app, either the online app or the polysimul app to solve. So, and then you need to take everything to one side. So if we took these here and we set them equal to each other, and then we took all terms to one side, we would get x squared minus 4 equals 0. And so we want to solve that with the polysimul app. Okay, which I'm not going to put up here now, but you know how that works, 1, 0, negative 4, and then you would get negative 2, and there's a y that goes with that, because we're doing a system, and you would also get 2, and there's a y that goes with that, because we're doing a system. So how do we figure out the y? I go back to the linear function. Let me zoom in a little bit here. And put these both in to get the y. So 2 times negative 2, negative 4 plus 1, negative 3. And then 2 times 2 plus 1 is 5, and for the other y. So those are the 2 points where your graphs would meet. And so you just go and plot those 2 points. And then 2, 5. There it is, and let me go dig out my nice little ruler. And now that I got my nice little ruler, you can draw the line through that, and also the quadratic will go through this. So the hardest part of this is going to be making the quadratic function. And so you may want to go onto a graph, or you may actually want to put both of these on there, and it's just good to do it so you can see, you know, is my setup right? 2x plus 1. So don't get confused here. This is what we did to solve it, but you need to put the originals in. And then just take a look on the table. So the first one is the quadratic. And so you see the whole pattern again, the negative 1, negative 4, that's where the vertex point is. So you need that. And then just a couple of more points by symmetry. So that's 1 left, so it's going to be right there for the symmetry point. And then you can wind up to, so we also have x-intercepts of 1, 0, and negative 3, 0. We have that. Just do your best to do a nice little sketch, of course. But you have to make them meet in those points. You can also tell on here where the y's are the same. So 2, 5, here it is, and negative 2, negative 3. That has to be, you have to see the same y's. Now, what happens if they're not nice? I get all that, but it's important knowledge to know how to find them on your table if you can see them. But what happens if they're not nice? They're just not nice. You get your ugly x values, and then you plug them into the linear equation, and you get your ugly y values, and you go about graphing the same way, getting the vertex and using points on the line. And so you can have 2 solutions, 1 or none. And what I want to do is leave a little bit of graphing for you, and you can check your answers. This will give you 1, 2, and none. I'll give you that much, but I want to give you a little practice with graphing. So approaching any of these without the graph just means, and I'll do one of each. I'll do 5, 6, and 7, and then you have problems to do here for more practice. Do as many as you think you need to get the general idea. The more important part is to be able to do them without graphing. That's the idea. Set them equal. Take everything to one side. So 2x equals 0. Run it through PolySimul 2, or the online app that will find these zeros. A is 1, B is 2, C is 0. Okay, we've done that a ton. And you're going to get 0 and -2. Now I want to tell you this, when you get your two answers, those are just the x values. You have to go and get the y values also. These are coordinates that are a solution, just like I wrote down up there. X is 0, take it into the linear function, it's easier. Then you get y is -2. X is -2, so 3 times -2, -6, -2, -8. And if you go to the table, you should see 0, -2, -2, and -2, -8, -8 for the two y's. Every time. Every single time, if there's a solution, you will see that equals x plus 6. So we have -x squared minus 4x minus 4. Okay, we'll just do this once so you can see it. Now I'm going to take off the a plus bi, so we did that just because we wanted those imaginary solutions from before. Now we just wanted, if there's not a solution, we just want to know that there's no real solution. So -1, -4, -4. -2, -2, so this is the double. So you only do it once, of course. But this is where the vertex would sit on the x-axis if you're drawing the quadratic. So -2 plus 6, just go to the linear function. And here's one where there will be no solution. And so when you do this, you would see subtract 2x over, subtract 4, you would see that there's no solution. Back to coefficients. No real roots found. Okay, so empty on that. Again, just use that little arrow there. That basically is linear quadratic systems. Again, you have the added extra of the graphs. Okay, just make sure that you graph the vertex value when you graph the quadratic, and that we've worked a ton on that. These are actually pretty simple when it boils down to it. I see the SAT generally has one of these, some question about these. The last one, here you're going to get not nice solutions. Solutions, not nice. So the table feature will be out of order when it comes to number 10. And let's just do 3. One more of these for the hay of it. Equals 3x minus 1. So x squared minus 7x plus 6 equals 0. Everything on one side. Oh my word. Everything on one side. So subtract the 3x over, making -7, and add the 1. And then run it through. So we're done with the quadratic formula, so I will allow you to use technology when we have to find solutions. Okay, so 6 and 1. Make sure you understand. We are finding a system. We are solving a system, so there are coordinates for solutions. So 6 goes in, use the linear function, 18 minus 1, 17, and then 3 goes in, 3 minus 1 is 2. In this unit, since these are really easy, you have a giant solving linear systems packet to do, which I've done 2 videos for. you need to spend a lot of time on that, going back on what are linear systems and all the different things, because those are on, you know, various standardized tests also. Um, a vast majority of those, I do allow you to use the other half of this. Go back to the main here. And I also, or an online linear system solver. So understand that we're learning how to use technology to solve linear systems. And then how do you know you have linear systems in a particular problem? What's the way to recognize that they're there and the types that you would see?